So I'm going to go through just a bunch of questions as I roll through this. My recommendation isn't necessarily to write everything down, but to be tracking along, asking yourself questions, possibly writing down notes to yourself about, I got to make sure I have that on my note card and that on my note card as we go through these scenarios. So in this is getting back to way back when we talked about areas and things like that, and we're going to actually then develop a formula for it. So Colorado is shaped like a rectangle whose length, so let's do that's why. All right, so it's shaped like a rectangle, where it says that the length is 1.3 times its width. So if we say that's the width, then this would be 1.3 times the width, or 1.3 W. And the perimeter of Colorado is 2070 kilometers. So you got to remember what's perimeter. So perimeter is the distance around. So distance around means I'm going to take all four sides and add them up. W plus 1.3 W plus 1.3 W. Different than if it said area. So then there we have 4.6 W equals 2070. And then you run to the calculator and say, well, 2070 divided by 4.6. Is 450. So the width is 450 kilometers times 1.3. The length is 585 kilometers. So after you solve it, always a good idea then to go back and make sure that you actually are answering the full question. Find the length and the width. Oftentimes, you take an exam, you're working through a problem, you find an answer, and then you forget to go up and ask and read and realize what exactly was the question asking. All right. So then working through this one, again, when it says solve, ultimately it's always it's a good idea to be thinking, what do we mean by solve? At the end when we say solve, it's like x equals something, or in this case it's going to be this symbol. Well, that means I need to have x all by itself, numbers on the other side, so I need to start working my way through to get all my x's to one side and all my numbers to the other side. But there's a fraction which causes many people pause. When that happens, if you multiply by the denominator, I can clear that fraction away. So then I will have 3 parentheses, x minus 4 greater than or equal to 7x plus 14. And then I look, okay, can't do anything inside the parentheses. I need to get rid of the parentheses so I can get all my numbers and variables by themselves. So I'm thinking distributive property. 3x minus 12 greater than or equal to 7x plus 14. And then I need to decide, where do I want to put all my x's? Habit for most people is to move their x's to the left and the numbers to the right, which is okay, except that I have more x's on the right side. So I'm going to actually prefer to move my x's to the right and my numbers to the left. So I'm going to subtract 3x from both sides, always both sides. And that'll move all my x's to the right side. And then I'm going to move my numbers to the left side. And when I do that, 3x minus 3x is 0 x's. Here's really watching your negatives. Negative 12 minus 14 is negative 26. Greater than or equal to 4x. Because 7x minus 3x is 4x, 14 minus 14 is 0. Divide by 4. Inverse of multiplying is dividing. So I will have, now down here, I had it like this, which is not exactly where I end up with. I end up with x is over here, my symbol stays like this, and I have negative 13 over 2. I just reduced that. And then that would be done. If you want to write it the other direction, I can take this and rewrite it as x less than or equal to negative 13 over 2, where I just switched everything, like the entire order. The x, the narrow end is at the x. The wide end is at the negative 13 halves. Those are identical statements. Okay. So again, as we're going through these problems, you're thinking, okay, what elements do I need to write down? What do I need to be careful of? If you had moved the 7x to this side, we would have had 3x minus 7x, and that would be negative 4x. When you were done and divided by negatives, it's remembering that when you divide by a negative with an inequality, and it only, like when you multiply or divide by a negative, this sign flips directions. And the idea is if I'm changing the signs, then I'm changing the sign. But here I divided by a positive, so there's no need to change the direction of that sign. Is that a solution of that equation? Another way that that question can be phrased would be evaluate this equation for this point. So if that's the case, to find out, is it a solution? Does this point work in this equation? Means I'm going to take these numbers and just substitute them in. This is my x, goes there for x. This is my y, goes in there for y. So I'll have 3 times negative 2, which is 3 times x, plus 2 times 3, 3 was the y. And I'm going to find out, does that equal 0? Well, negative 6 plus 6 equals 0. 0 equals 0. I need to answer the question, yes. Negative 2, 3 is a solution. So again, going back and making sure you're actually answering the question. The math is one part, but then answering the question is a big component of that as well. All right, solving a system of equations can be done 2 different ways. Well, I mean, there's multiple ways. I mean, I could do graphing, but I'm not going to do graphing. I could do matrices, but that oftentimes is a little bit more complicated when it's only 2 variables. So usually when I have a scenario like this, I'm either going to use substitution or linear combinations. What I'm going to do first is actually linear combinations. Linear combinations is a fancy way of saying, if I add these 2 equations together, is there something I can do that will make one of those variables go away? And the answer is, just looking at it, the answer is no. Because if I add x and 2x, they don't disappear. If I add y and negative 3y, they don't disappear. But if I were to multiply that first equation by 3. If I multiply that first equation by 3 and then rewrite it underneath here, it's going to be 3 times x, which is 3x, 3 times y, which is plus 3y, and then 3 times negative 3 is negative 9. And then I add those equations. 2x plus 3x is 5x. The 3y and negative 3y, they add to 0. 19 and negative 9 adds to 10. And then I divide by 5, and x equals 2. But I'm not done. I need to bring back that first equation. And the first one's easier. I can use either one. X plus y equals negative 3. I'm going to take this x and substitute it in. 2 plus y equals negative 3. Subtract 2 from both sides. Y equals negative 5. My answer will be 2, comma, negative 5. The x was negative 2. That's the x coordinate. The y is negative 5. That's the y coordinate. When we're solving a system of equations, what I'm doing is I'm finding out where they intersect. That's what it means. Graph two lines, plot them, see where they intersect. They will intersect at that point. Now I said there's two ways to solve this. The other one would be using substitution. To do substitution, I can do the same thing, but I need to have it solved for a single variable. So I'm going to take this equation and solve it for x. So if I solve it for x, that means I subtract y from both sides. Negative y minus 3. So again, all I did here is I subtracted y from the left, and I subtracted y from the right. So I'll have negative y over here. So x equals. I do that so that I can use x and replace it in the other equation. So the other equation is 2x minus 3y equals 19. And this x is right there, which means I'm going to take this and put it in for that x. So it'll be 2, my pen, 2 times, and then I substitute that in, negative y minus 3 minus 3y equals 19. I'm going to do distributive property, so that'll be negative 2y minus 6 minus 3y equals 19. Combine like terms. There's a negative 3y and a negative 2y for a grand total of negative 5y minus 6 equals 19. Add 6 to both sides. Negative 5y equals 25. If I added 6 to both sides, divide by negative 5. Y equals negative 5. And if you look, that's what I got over here. You will get the same answer. And then it would be just like we did on this side. Pick one of the equations. I like just the x plus y equals negative 3. This is y, substitutes in there. X plus negative 5 equals negative 3. Add 5 to both sides. X is 2. So again, x is 2, y is negative 5, so the point is 2 comma negative 5 for x comma y. It's the same value, same thing. You can do either way. For the exam, I don't believe I ask you to do it one specific way. I think I just say solve the system of equations. So if you prefer substitution, do substitution. If you prefer linear combinations, you can do linear combinations. If you like matrices, you can do matrices, but do not do graphing. Because it'll say solve algebraically. Well, that's different than solving graphically. Simplifying is a matter of using all the, maybe we're thinking of PERMDAS. PERMDAS is a part of simplifying. In this case, I see that, I have exponents and exponents and all stuff going on, which means I'm going to do properties of exponents. I'm going to start with what's inside and see if I can simplify what's inside the parentheses first. So I look for common bases. Now again, if you don't know all the properties of exponents, that would be something you're writing down a note to yourself. That's what you're doing right now. Properties of exponents. I better write that down. I better get those listed so I remember how to do them. I have same bases, x and x, and I'm dividing. Same bases and dividing, the property of exponents is subtraction. The 5 stays as a 5. There are no other numbers to deal with. I have x to the negative 3 minus 2. Negative 3 minus 2. Again, when it's division, same bases, numerator exponent minus denominator exponent. Negative 3 minus negative 2. And the whole thing is still raised to the negative 2 power. Simplify it, what's inside, so 5. So negative 3 minus 2 is negative 5. And then the whole thing is still to the negative 2 power. So now I have stuff inside of parentheses, all multiplying, and I have powers raised to powers. Powers raised to powers, we multiply exponents. That's the property of exponents there. Now, if you don't see it, you have to remember and recognize that the 5 does have an exponent. It's 1. So when I have powers raised to powers, I'm going to multiply exponents. 1 times negative 2, negative 2, x, negative 5 times negative 2, positive 10. Now that I've been able to work through combining bases, I've worked through getting rid of the parentheses, I look at what I have left and say, well, 5 is one type of a base, x is another type of a base. They cannot be combined. They are different variables or different items. They have different bases. If they're different bases, I cannot combine. So then all I have to do at that point is say, well, ideally, we want to have positive exponents only. X to the 10th is already a positive exponent. It will be x to the 10th. 5 to the negative 2, negative means I need to move it to the denominator. And when I do, negative exponents, when you flip it to the other side, negative exponents become positive exponents. Is that the only way I could have started that problem? No. I could have also done this inside the parentheses, left the 5 in the numerator, and then had x squared, x cubed in the denominator. Again, if it's a negative exponent, I can move that whole thing to the bottom, and then the exponent becomes positive. Now I have same bases, x squared, x cubed. I would have 5 over x to the 5th, to the negative 2. Negative exponent means I move everything to the other side. This could then be considered x to the 5th over 5 squared. So again, all I did there was like, well, the negative exponent means everything gets flipped. 5 goes to the denominator goes to the top. And then from here, 5 times 2 is 10. 5 squared is down there. Do you need to make it a 25? No, I would actually say don't do that. I am mostly looking at, or I'm entirely looking at, shouldn't say mostly, I'm entirely looking at in this scenario, are you using combining the bases? Are you using powers raised to powers? Properties of exponents. This is all about properties of exponents, not that you can plug, because if you put 5 to the negative 2 power into your calculator, it's going to give you a number like 0.02, 0.04, 0.04. Like I don't want 0.04. I want 5 squared in the denominator. If you make it 25 at the end, that's fine, but you don't have to. Going to solve, which means in the end, I need to have x equals something. That's where I'm ending up. But in order to do that, I look and say, well, I have fractions, which means in order to use fractions, I need to have common denominators. This problem brings a lot of pieces into play. So, first thing first, I see this thing right here. X squared minus 9 is a difference of squares. And I remember, or should remember, the difference of squares factors x plus 3, x minus 3. So that denominator can actually be replaced with x plus 3, x minus 3. Now, if you don't see difference of squares and recognize it, highly recommend having that written down. They will show up again. You've seen it already on the first 2 exams. All right. So now I look and say, all right, what is my common denominator will be x plus 3, x minus 3. This just has x minus 3, which means I need to take this and multiply it by 1. As x plus 3 over x plus 3. Times 1 over x minus 3. This fraction has x plus 3 in the denominator, so it's also going to be multiplied by 1. But the special form of 1 is x minus 3 over x minus 3. So I'll have x minus 3 over x minus 3 times 2 over x plus 3. And this equals 1 over x plus 3, x minus 3. So if I'm looking at this, I'm like, all right, that's all going on. As I look to the left-hand side, this fraction has x plus 3, x minus 3 in the denominator. This fraction has x minus 3, x plus 3, so they can be other ordered as well. This one, x plus 3, x minus 3. I have now a whole set of fractions whereby the denominators are all the same. If the denominators are the same, and these fractions all have to be equal, that means the numerators have to be equal. So what happens is, once I get my common denominator, I can then look only at the numerator to solve. I have over here x plus 3 times 1, which is x plus 3. Here I have x minus 3 times 2. So that's 2 times x minus 3. And on the right-hand side, it equals 1. And now I'm down to algebra. Just did simplifying there. Add 3. 3x equals 4. X equals 4 thirds. Big concepts there. Recognizing difference of squares, factoring, finding the common denominator, that's fractions, and then when I have all same denominators with an equality, that means numerators are the same. Boom, boom, boom. Solve the equation. Factoring, step 1 of factoring has been and will remain, is there a GCF? Is there a value or a number that can divide into all 4 of those items? 28 is divisible by 7 and 4 and 2. 27 is divisible by 9 and 3. 10 is divisible by 5 and 2. So the answer is no. There is not a single number. So this does not have, this is divisible by 2, but that one's not. This one is. This has an x, that has an x, this does not have an x. So there is not a greatest common factor. Step 2 is it a special form? Is it a difference of squares? Nope. Step 3, can I use just a quick process of saying, well, what multiplies to negative 10 and adds to negative 27? Can't do that either because my first coefficient is 28. So factoring at that point becomes this. Up here goes the first term, 28x squared. In the bottom, it's a times c, which is negative 280. 28 times negative 10. And then I am trying to think what numbers multiply to negative 280. Well, we already listed 2 of them. 28 and negative 10, which means negative 28 and positive 10. When they add, do they add up to negative 27, either of them? Nope, that adds up to 17, that adds up to 18 and negative 18. I need negative 27. So then it's going, all right, what else goes into 280? Eight does. 8 and 35, so it'd be negative 8 or 8 and negative 35. And what do those add up to? These add up to, that'd be 27. These add up to negative 27. Negative 27 is my goal. This is my pair. So I did the X. Now I need to do the box. Upper left-hand corner, this is 28x squared. Bottom right is negative 10. First term, last term. These two numbers that I did from the X go into the boxes. Does it matter which one? Not really. It's negative 35x. It's not a very neat looking negative 35. Let me make that better. Negative 35x, positive 8x. And then I have to start coming up with numbers. So here's what I would do at this point. 28 and 35. Is there a number that goes into both of those? $35 is 7 and 5. Does 7 go into 28? Yeah. How many times? So 7 7x. Well, if that's 7x, that means this is 4x. Because that gets me to 28. X and x is x squared. 7x times what is negative 35? 7 times negative 5. 7 times negative 5 is negative 35. And then the x is there as well. Then going down, 4x to 8x, this would have to be 2. Because 4 times 2 is 8. And then I look to say, does negative 5 multiply to negative 2, or positive 2 to give me negative 10? Yes, I have the right numbers. Which means those are the factors. 7x plus 2, 4x minus 5. And with my x, I didn't finish that up. This was the 8x. This was the negative 35x. Once I found them, I went to my box. So again, remembering in the x, what goes in the upper part, that's the first term. The bottom is the last term times the first term, 28 times negative 10. And then I'm looking for numbers that multiply to the last term, that add to the middle term. Then in the box, first term, last term, and the two things I found from my x. And then I have to go through and try to, do some factoring again there. All right. Up here, there's no equal sign, so I'm not solving, just factoring. Factoring. Is there a greatest common factor between x and 4? No, there's not. Is this a special form? Yes, it is. It is the difference of squares. So difference of squares is, I'm thinking, a squared minus b squared. Is the first thing something squared? Yep, it's x squared. Is the second thing something squared? Yep, it's 2 squared. 2 times 2 is 4. It factors into, up here, if it's a squared minus b squared, it's a plus b, a minus b. So here this would be x plus 2, x minus 2. Next one. Is there a greatest common factor? Are x and y have anything in common? Nope. Is it a difference of squares? Yes, it is. It's difference. This squared minus that squared, it factors into x plus y, x minus y. Next one down. Are 4 and 25 divisible by the same thing? No. Are x and y divisible by the same thing? No. Is this a difference? Yes. Are they squares? Yes. So when looking at that, it's harder to see, but this would be 2x squared, because 2 times 2 is 4, x times x is x squared. 25y squared would be 5y squared, because I'm saying, well, 2 times 2 is 4, 5 times 5 is 25, x times x is x, y times y is y squared. So this would factor into 2x plus 5y, 2x minus 5y. Fourth one here on the page, are 8 and 50 divisible by the same number? They are. They're divisible by 2. Are x cubed and x divisible by the same number? By the same thing? Yes, they're both divisible by x. So then this will be 2x times 4x squared minus 25. 8 divided by 2 is 4. X cubed divided by x is x squared. 50 divided by 2 is 25, and the x is reduced to 1. And then I see this, and I go, am I done? Well, there is an x squared. And is this a difference of squares again? Yes. This is 5 squared. This is 2 squared. That's x squared. This would then factor completely into 2x. That 2x stays out in front. And it would be 2x plus 5. 2x minus 5. Seeing and recognizing difference of squares. Solving. Most common mistake in a problem like this is someone's going to start to multiply it out. When we are solving for x's, and there's going to be powers. How do I know there'd be powers? If I multiply 5x times x, I get 5x squared. To solve when I have powers, my goal is factor it completely first and then solve. Because what I have going on here is I have 3 things multiplied. This times that parenthesis times that parenthesis. I have 3 things that are multiplying to get 0. If it multiplies to 0, that means either 5x equals 0 or x minus 4 equals 0 or 8x minus 3 equals 0. If I'm multiplying to get to 0, one of them absolutely has to be 0. So over here, if 5x equals 0, solve for x, so I divide by 5. X is 0 over 5, which is 0. So x is 0, or, all right, gonna solve for x, move the number over, add 4 to both sides, x equals 4. Or, then I gotta solve this for x, so I'm gonna add 3 to both sides, 8x equals 3. Then divide by 8, x equals 3/8. So either x is 4, x is 0, or x is 3/8. I could take any one of those 3 numbers, put them back in up here, and 3/8 will make this 0. So 0 times whatever the other stuff is always 0. If I put 4 in, 4 minus 4 is 0. And 0 times anything else is 0. Put in 0 here for x. 5 times 0 is 0, and 0 times all the rest of it is 0. So solving for powers, we're going to factor, and then hopefully, well, set it equal to 0 first, then factor, and then solve. So that's what we have going on right here. We have powers. Set equal to 0. Good. Let's factor. Are 2, 3, and 35 divisible by the same number? No. This has an x squared, this has an x, this has no x's, so there's not a greatest common factor. Is this a difference of squares? No, it is not, because there's 3 things. Difference of squares only has 2 things. So then I go, all right, then I need to factor this. And for practice, 2x squared. Down here is negative 70. 2 times negative 35. And then I'm trying to think of 2 numbers that multiply to negative 70. I just did 2 of them, right? Negative 2 and 35. 2 and negative 35. Do those add up to 3? No. They add up to like something 30. What else multiplies to 35? Or sorry, multiplies to 70. Multiplies to 70. Multiplies to 70. 7, so I guess negative 7 and 10. 7 and negative 10. Do either of those 2 pairs add to 3? Negative 7 and 10. Negative 7x, 10x are the 2 numbers in that x box. So now I actually, or in the x, now I have to make my box. 2x squared and negative 35. Most common mistake is people put the 70 over here. I use the 70 in the x, the negative 70, but in the box, I use the first term and last term. Last term, first term. These numbers here, that's what comes from the x. Negative 7x and 10x. And then what I'm going to look at here is I'm going to say, all right, well, this is a 2 and a 10, so I'm going to make this side the 2x. I'll make the top part the x. X times what is negative 7x? X times negative 7. Over here, 2x times what is 10x? That's 5. And then I double check. Does negative 7 times 5 equal negative 35? Yes, it does. So my factors are 2x minus 7, which were these. And then x plus 5 for these. And my whole thing still equals 0. Two things are multiplying to get to 0, which means 2x minus 7 equals 0, or x plus 5 equals 0. The left equation, add 7, 2x equals 7, divide by 2, x is 7 halves. Or subtract 5 from both sides, x equals negative 5. Simplifying, ugly looking fractions. So the one in the numerator has a single denominator. The one on the bottom does not. I'm going to take this first. I'm going to kind of take that over here. And I'm going to see if I can get that written as a single fraction. So right now the denominator of the x is 1, although we typically don't write it, but it's there. I want a common denominator. My common denominator will be x. So I need to multiply that first thing by x over x. X over x is 1. Doesn't change the value. So when I multiply here, multiplying fractions, we just multiply across. It will be x squared over x minus 4 over x. And since they have the same denominator, I can rewrite that as x squared minus 4 over x. Now I'm going to take this whole fraction and rewrite it. X plus 2 over x, that's the numerator. The denominator I simplified into x squared minus 4 over x. Fractions divided by fractions. Dividing by a fraction, same as, there should be a phrase in your head already. Dividing by a fraction is the same as multiplying by the reciprocal. So I take the numerator, x plus 2 over x, and I'm going to multiply it by the denominator flipped. Dividing by a fraction, same as multiplying by the reciprocal. X times x plus 2, x times x squared minus 4. I wrote it like this. Can I simplify that fraction anymore? Certainly can. What's x divided by x? 1. So now I have x plus 2 over x squared minus 4. Does that look familiar? This down here is the difference of squares. So bring it all the way back to the left here. X squared minus 4 factors into x plus 2, x minus 2. In the numerator, I have x plus 2, not in parentheses, but you can put it there. And now it's easier to see that there is also something divided by itself. Anything divided by itself is 1. So in the numerator, I have 1. In the denominator, I have x minus 2. Now, I am finished. Mistakes that I see people make, if you look over here, they'll try to take this x and reduce it with that x. Cannot happen. This x is then having subtraction attached to it. We can only reduce when we're multiplying, which is why down here, this was multiply, this was multiply. This is divide. Multiply and divide, I can reduce. Or over here, I had this whole parenthesis being multiplied by this whole parenthesis. This whole parenthesis is identical to this one, so the whole thing reduces to 1. Not individual parts. Cannot reduce if something is trapped by addition and subtraction. We're going to divide using synthetic division. Synthetic division starts with writing the coefficients 2, -1, -8, -1, and I better make sure I'm not missing anything. What I mean by that is there a coefficient for every x going down? There's x cubed, x squared, x's, no x's. There's nothing missing. These stay as is. Synthetic division is, I think, what makes this 0. positive 2. 2 minus 2 would make it 0. For synthetic division, I take the opposite sign. Procedurally, the negative 2 comes down, or sorry, the 2 comes down, 2. And then I go 2 times 2, and it goes here. All right, so 2 times 2 to there, and that's 4. What I like about synthetic division is we add. With regular division, we subtract, and then you get a lot of negatives, and it's hard to make sense. So we go negative 1 plus 4 is 3. Then we go 2 times 3 to right there. 2 times 3 is 6. Then we add negative 2. Negative 8 plus 6 is negative 2. 2 times negative 2 goes here. 2 times negative 2 is negative 4. We add negative 5. But we're not done. My equation then, that 2 translates down here to 2x squared. Because I'm dividing by an x, the x cubed goes down to x squared. Because I'm dividing by an x, the x squared becomes x, and it's a positive 3, so it's plus 3x minus 2. And then the remainder is minus 5 over x minus 2. I have 5 left, and I was dividing by x minus 2, so it's 5 over x minus 2. Now, in the future, if you decide to take pre-calculus, this will tell me that there will be an asymptote related to this when you go to graph it, but we'll not worry about that now. Sometimes people wonder, but why are we doing this? Why does it matter? Well, if you're going to take pre-calculus, this is a precursor to that next step. Solving when there are radicals and roots. I need to get the root all by itself on one side. I'm going to add 5 to both sides. I'm going to subtract an x from both sides. On the left, I will have negative square root of x plus 1. On the right, I will have 5 minus x. I'm going to rewrite it as negative x plus 5. I just like having my variables written first. It's a preference. I almost have roots all by itself. I got this negative. Want to get rid of the negative? Multiply everything by negative 1. Now it's going to be a positive x minus 5. Now I can get rid of the square root. The inverse of square rooting is squaring. Squaring the whole side. When that happens, I'll be left with x plus 1. On the right-hand side, I have square, which means times itself. Do not make the mistake. Some people will take this and say, well, it's going to be x squared minus 25, and that would be wrong. Squaring cannot just come in when there's adding and subtracting. When we do properties of exponents only works if I'm only multiplying. Here there's subtraction, so I cannot do properties of exponents. This I will FOIL, first, outside, inside, last. Firsts, x squared, outside, negative 5x, inside, negative 5x, lasts, negative 5 times negative 5 is positive 25. X squared minus 10x plus 25. I have squareds. So first step in solving for squareds is setting it equal to 0. Subtract x and 1 from both sides. I have 0 equals x squared minus 11x plus 24. I could do the X box method again, or I could look and say, what two numbers multiply to negative 24? Now that my coefficient here is 1, I can just go straight to multiplying and adding. What multiplies to positive 24 that adds to negative 11? So I have things like negative 6 and negative 4. They multiply to positive 24. Do they add to negative 11? No, they add to negative 10. What else multiplies to negative 24? Negative 8 and negative 3. Do they add to negative 11? Yes, they do. My factoring will be 0 equals x minus 8, x minus 3. Almost done. I have two things multiplying to 0. So that means x equals 8 or x equals 3. Because 8 minus 8 is 0, 3 minus 3 is 0. To get my solution. So a problem like this is nice on an exam because it covers the aspect of solving for square roots. It gets to factoring a quadratic and then solving when things are multiplying to 0. So multiple things that can be assessed in a problem like this. Now, if you did not know how to factor down here, completely acceptable if you want to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a equals x. 100% not a problem. You probably need to write down that you have the actual quadratic formula to make sure you don't have anything wrong. If you ever, and here's a pro tip on taking the exam, if you ever use the quadratic formula on the exam or any place, write the equation down on the test to show me that you know what you're, like, this is what I'm doing next. I'm using quadratic formula, so you write down the formula. The other advantage it has is if you take it from your note card, you write it down on your exam, and you somehow mistakenly have a positive where it should be a negative, I can see, oh, they wrote the equation down wrong. Okay? Now, if it's like really close, if you forget that, if it's negative b, but you wrote down b plus or minus, that's just an oops. The formula is negative b. And if you have it on your formula card, I'll look at your formula card and go, oh, they had it on their formula card the right way. They just wrote it on the test wrong.
So just to do us 5 out of 5, would you?
Then you'd still get the full credit on that if you would work it through. Yeah. Because, again, I'm not assessing you on can you write the formula down. You were like looking and going, oh, I know the right formula to use. And then you write it down and you're like, but you wrote it down wrong? That's just a transposition error, not an issue. That's not math to me. That's just you made a clerical mistake. Now, can clerical mistakes sometimes be bad? Sure. But I'm not assessing you on that. It's on, did I know that it was quadratic formula? Yes, I wrote down the formula, plugged in the numbers, I got a solution. We'll go with that. Here's f of x, here's g of x. We need to find f of g of x. This is composite functions. So f of g of x means I'm going to take g of x, which is this equation, and put this in the place of x in the other equation. So it'll be 3, instead of x, it'll be x plus 5 over 3 minus 5. So f of g of x means whatever's the second one, the of g, this g of x goes into the first equation and replaces the x. And then I simplify. 3 times that whole fraction, well, 3 is the denominator, 3 is the numerator. It will be x plus 5. The 3's reduce, leaving me x plus 5. And then it's minus 5 equals x. And that's it. Done. Second part down here says, now find the inverse of f. So f of x is equal to 3x minus 5. And I can also write that as y equals 3x minus 5. To find the inverse, I change the y to an x. I change the x to a y. And then I solve for y. I want to solve for y. So that means I'm going to move this 5 to the other side. So I add 5 to both sides. X plus 5 equals 3y. Then I got to divide by 3. And that is the f inverse of x. Now, if you'll notice, this, the inverse of f of x, was the same thing as g of x, x plus 5 over 3. If you ever do f of g of x and your answer is x, that means they're inverses. That's one way to check if two equations are inverses. So if an exam question says, are these two equations inverses? I can either do it like this in green, and show that one is the same as the other one, or do f of g of x and get x as my answer. Both of which would prove that two functions are inverse functions. Here we got to solve, remembering the relationship between logarithms and exponents. The base of this logarithm is 5, so the base of an equation is going to be 5. The exponent in a logarithm, right, this is the base, this is something, and this is something. Do you remember which one's the exponent? No, the 3. What the equation equals in a logarithm is the exponent in an exponential form. What's inside of the logarithm is what it equals. And then 5 cubed is 125. Biggest thing that we're assessing for on this equation, this question, is can you convert from logarithm to exponent form? The only way that this would not be, like if you got to here and just ended it there, you'd be a 4. You get the full credit. If you did mistakenly, like if you did this instead, 15 equals x, it would be knocked down to probably a 3. Because instead of doing 5 cubed, you did 3 times 5. And that's a big mistake, like mathematically. 5 cubed is not the same as 3 times 5. 5 cubed, 5 times 5 times 5. Which essentially means when in doubt, don't simplify exponents. Unless you're really confident that you're doing it the right way. Just leave it as 5 cubed, you're done. Yep. Yeah. So like I said, if you left it here and said done, you're going to get 4 out of 4. If you mistakenly went over here and said this was your answer, now it's going to be a 3 out of 4. So instead of essentially correct, you're mostly correct. just because that's a big mistake. So now we're going to convert this exponential into logarithmic. What's my base? My base is 10. So it's going to be log base 10. I'm going to have an equal sign. I'm going to have something here. Which one's the exponent? In a logarithm, we just wrote it on the previous slide. This is the exponent. 3x minus 2. Yep. And then what it equals in an exponent, that's what's inside of there. So it says convert to exponential. At that point, we would be done. On an exam, it would say convert to exponential, part A. Part B would then say solve for x. Well, log base 10 is what your calculator is. If you just look at the log button on your calculator, it is base 10. So then we go to the calculator. If you don't know how to use logs on your calculator, you should probably figure that out. But I have 0.01, and I'm going to take the logarithm of that. And I find out that log base 10 of 0.01 is negative 2. Negative 2 equals 3x minus 2.
And then we're done with that?
Oh, I got to solve for x. Add 2. X equals 0.
Wait, don't we add 2 to both sides?
We added 2 to both sides. Plus 2 here, plus 2 here. Negative 2 plus 2 is 0. On the right-hand side, I'm just left with 3x. Then I divide by 3. X equals 0.
I thought it was just
Yep. Now we're going to simplify. Logarithms are exponents, so we're thinking about what are the properties of logarithms. Logarithms that add can be combined, if they're same bases, into multiplication. So I'm going to start with these two. Combine them. It would be log base 3 of 18 times 2 minus log base 3 of 9. And now I remember, well, subtraction, when I combine together of same logarithm bases, is division. So now I'll have log base 3 of 18 times 2 over 9. And then I can simplify numbers inside. 9 goes into 18 twice. This would be log base 3 of 4. And that's it. Not asking you to find that number. That would take more work on your calculator. If you wanted to, let's just say we did, because that's another logarithmic property, to change the bases, or actually in this case to find out what it actually equals, this can be rewritten as log base 10 of 4 over log base 10 of 3. Change of bases, you go log of the top one, log of the bottom one, over each other in a fraction. And then you can plug that in your calculator and find an actual number. I don't believe I'm going to ask a question about that, though. Similar idea, but now it's solve. Using logarithms, we're going to combine these two together. It will be log base 2. I'm adding, which means these two things multiply. X times x plus 1. And that equals 1. Well, how does that help me? Well, I don't know log base 2 of anything, so I think, is there a way I can get out of logarithms? Certainly. I'm going to convert this into exponential. My base is 2. My exponent is 1. And it will equal what's inside of the logarithm. x times x plus 1. Oh, it's an x minus 1. Up here it's minus 1, and I wrote it as a plus, so I need to change that. X minus 1. That down there is x minus 1. So converting, so first it's using logarithmic properties to combine them. Then it's using properties of logarithms to convert it back into an exponent. 2 to the first power is 2. And this will be x squared minus x. I have x squareds. To solve for x squareds, I need to set it equal to 0. Subtract 2 from both sides. And now I have a quadratic. I can use Xbox, I can use quadratic formula, or I can just look and see, is there a way that I can factor this with two numbers that multiply to -2 and add to -1? -2 and +1. -2 times 1 is -2. -2 plus 1 is -1. This equals 0. X equals 2, because if 2 minus 2, that would be 0, because it multiplies to 0. This one, x equals -1. Combinations and permutations. This was a couple days ago. If 10 people are in a room, how many ways can they finish first through fifth in a game? Is this a combination or permutation, and why? Does the order matter?
No. It's a permutation.
Finishing first through fifth in a game. Is fifth place different than first place? Yes. Order matters. If order matters, it is a permutation. So the first part of that would be, it's a permutation because the order of the places matters. And then it says set up but don't simplify the equation. So it's a permutation, so I'm going to write down the permutation equation. NPR equals n factorial over n minus r factorial. Then plug in the numbers. This is where I'm going to say, all right, can do you know which one's which? N is the total number of people. 10 factorial. 10 minus first through fifth, so I'm choosing 5 people, factorial. Which would be 10 factorial over 5 factorial. Done. Now we could finish that if we wanted to. It's not hard. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is 5 factorial. So I just convert, like, the reason why I did that is because the denominator is 5 factorial. Those reduce to 1. And I'm left with 10 times 9 times 8 times 7 times 6, which is a big number. But I'm just going to leave it like that. So what the question really in yellow is all I was asking for. Can you tell which one it is? Can you put the numbers into the equation the right way? And then do some minor simplifying, just subtracting what's inside there. You don't have to finish it out on your calculator, though. All right. Mach number is a measurement of speed, named after the man who suggested it, Ernest Mach, a long time ago. The speed of an aircraft varies directly as its Mach number. The Concorde jet, which is no longer in service, at one point was the only passenger jet that traveled beyond the speed of sound. Had a maximum speed of 15.02.2 miles per hour, which is Mach 2.03. SR-71 Blackbird is a retired military that is said to travel at 2,200 miles per hour. What is the Mach speed of that blackbird? All right, we go back. Speed varies directly. Y equals K times X. Y equals K times X is how we do direct variation. Inverse variation, recall, we're not going to use it on this one. Y equals K over X. But that's not what this problem is. We're doing direct variation. 1502.2 equals K times 2.03. That's the Concord numbers. I need to find out what the constant of variation is. 1502.2 divided by 2.03 is 740. That's my constant of variation. The equation then gets rewritten as y equals 740 x. Y was the speed, x was the Mach number. It then says the SR-71 Blackbird, retired military jet, fun fact, on its day of retirement, it flew from Beale Air Force Base down here in California out to Washington, D.C., where it was going to be retired. While it was flying across the country, it made a new airspeed record on its last day of travel. That's how good of a plane it was. Lasted for a long time. Anyways, it's said to travel 2,200 miles per hour. Miles per hour was the y, so 2,200 equals 740x. So 2,200, to solve for x, you divide by 740. X equals 2.97 Mach. That is 2.97 times the speed of sound, almost 3 times the speed of sound. Now that's the fastest recorded unclassified or declassified speed. There's pretty good belief that it traveled actually quite a bit faster than that. And the maximum altitude for that plane was also classified. Number of students who show up to an 8 a.m. class decreases 8% per week. Probably higher than that. If you're still here, if 285 students have an 8 a.m. class, how many show up after 13 weeks? So amount equals principal times 1 plus r to the t power. That's our equation for exponential growth and exponential decay. If it's growth, it's 1 plus r. If it's decay or decreasing, it's 1 minus r. Is this growing or decreasing? Decreasing. So my amount will equal the principal, how much I start with, times the rate, 1 minus 8%, 0.08, to the time, 13. 285 times 0.92 to the 13th power equals my amount. Order of operations says we do exponents before we multiply, so 0.92 to the xy power raised to the power of 13 times 285. So if you're doing this on your calculators, this would be a matter of just making sure you can set it up and then actually finish it out. 96.4, or about 96 students. So in 13 weeks, it goes down almost a third of the number of students who started with the class originally. After 13 weeks are still attending the 8 a.m. class. Slightly better than that today, although at 8 o'clock there was one person here. Well, 2 including myself.
At least we arrived.
No,
At least we are paying.
at least I showed up.
Yeah.
It's a pretty low bar you're setting for yourself.
At least it's a bar, you know.
You don't have crutches as an excuse. That slows people down. Now, if she were here, then you would have been really,
Yeah, I would have.
we would have heaped more shame on you.
Yeah.
Yeah.
What about she was late and
Write an example of an equation that is an ellipse and explain why it isn't a hyperbola or a circle. This was the last class where we met, where then you have to remember, all right, what does it mean to be an ellipse? To be an ellipse means that the x squared term and the y squared term are both positive, but
Sign.
the coefficients are different. Then I could do pretty much anything after that. Minus 2x plus y minus 42 equals 0. That would be an example of an ellipse. I'm not going to figure anything out with that ellipse, but that would be an ellipse. Why isn't it a hyperbola? If it's a hyperbola, then the x squared and the y squared have to be opposite signs. Right now, they're both the same sign. They're both positive. Why is it not a circle? Well, while it is adding, so if they're the same sign, x squared and y squared, if this number in front of the x squared is the same as the number in front of the y squared, then it's a circle. Same signs, circle or ellipse. Different numbers, ellipse. Same numbers, circle. If one of them is positive and the other one's negative, if this was actually negative here, that would then make it a hyperbola. Which gets us back to, like, this was the last slide from the day that we talked about conic sections. This one is adding.
Ellipse.
The numbers underneath are different. It's an ellipse. This one is subtracting.
Hyperbola.
Numbers under are different. Hyperbola. It's adding. Numbers in front are the same because it equals something. R squared. This is a circle. Actually, in the way this one is written, we could also say that the radius is 4. The center of that circle is 1, 2. What makes this 0? What makes that 0? Subtracting. This one's not negative. So one way that this could be like tricked up on you a little bit is if the original equation had this. This would be a trickier scenario. Not trying to trick you, but seeing if you're paying attention. This is negative. This is negative, which means they're the same sign. Different numbers, that would make it an ellipse. Here it's subtracting. Oh, but wait, there's no squared. If there's no squared on the y, but there is on the x, this is a parabola, which is a quadratic. It's the things that we've been doing. All right, so as we think about all the problems that we went through today, recommendation, watch the video again. When the slide comes up, pause before the work is done, see if you can do it on your own. And then watch the video and watch it go through. So this lasted about an hour and probably 15 minutes today so if you do it that way, you're probably talking about 3 hours of study time just to go through this. Does this represent everything possible that could be on the final exam? No. A good portion of it, yes. But going back through, you're going to see if you look back through videos from other times throughout the year, there will be other example problems that you'll see and that we've done a bunch of. Probably a good idea that those are going to be on the final exam. The online exam 2 quiz that you took is still open. You can retake it again until you get a 30 out of 30. And then if you take it again, as long as, it will only keep your highest score. So you can go in and try it again just to keep fresh on it, that kind of thing. You're working on getting your formula sheet done, having that available. Next Tuesday, which is the last Tuesday of regular class, will be an exam retake day. Who's thinking they're gonna be here for an exam retake? Which exam, 1 or 2? 2?
I'm gonna do one.
1?
Because
1,
I
okay,
got a better grade on
all right.
them.
And then next week, Thursday, a week from today, will be a time where I will be here and you are coming to me with questions to ask. You're looking at all the check your understanding problems you've done, something that you're still working on, and you'll bring an example problem and say, can we do this? Maybe it's using completing the square. Maybe it's quadratic formula, maybe it's factoring or simplifying or anything that we've covered in all the topics that we've gone through in preparation for our final exam, which is April 29th, Tuesday, 8 a.m. This room, 2 hours. As I said in the email, I will be here by 7:30 a.m. So if you want to start early because you think it's going to take you an extra amount of time or you just want to get done earlier, you can be here at 7:30 and you can start. Don't forget a calculator. April 29th, it's a Tuesday. Yep. We're normally at 8 a.m., so it's still an 8 a.m. on Tuesday.
It's a week from next week.
It's a week from next week. Yep.